Now, light will typically travel in a straight line. However, if it hits a surface, it can reflect then off of that surface, and then of course then will change a different, or cause it to go in a different direction there. So what's going to cause it to reflect then is always then this boundary between two media. Now it could be a hard surface, so you have say a mirror or just a very shiny surface. It'll bounce pretty much entirely off of that surface. But if you have light, say, hitting water as well, so the boundary then is going to be air and water is coming through the air and hitting the water, you'll get reflection off of there as well. And so again, it can be a hard surface where it basically all reflects, or you can get basically some of it reflecting and then some of it going into the media then, which will be going into refraction, which we'll get to in another day. Now, this one here, if you have parallel rays, they'll be reflected as parallel rays, and then you'll be able to actually still see that image. If you have a rough surface, so say you have light hitting, say, wood or something like that, you don't see your image in there because the rays then are reflected randomly, and so then that image information then does get lost. In terms of your law of reflection, again, the main thing you want to look at is just the angle in equals angle out. Now, your incident angle is the incoming ray, so your incident ray has an angle of incidence, and then your reflected ray has an angle of reflection. And so, again, the law of reflection is just that the incident and the reflected angles are equal to each other, so that's fairly straightforward. What you really need to watch with this, though, is that everything is measured to the normal line. So it is true that the angle of incident as measured from then the surface is the same as the reflected angle as measured from the surface. However, the angle of incidence is this very specific angle here measured from the incident ray to the normal line, which is just always perpendicular to the surface. And your angle of reflection is very specifically, again, this angle between the reflected ray and the normal line. So very often a question will give you the angle from the surface. And it's very easy then just to say, well, it's the same on the other side. But you always have to remember, if you're given the angle from the surface, your first step will be to take 90 minus that to get then the angle of incidence, which is always measured from that normal line. And then you can have the angle of reflection then from here. Or if you're given the angle of incidence and you're asked specifically for the angle from the surface, again, you have that 90 minus that. So watch carefully, angle of incidence, angle of reflection, always measured from the normal. If you're measuring from the surface, you'll specifically see that phrase from the surface then. All right, so this one here, we have a beam of light that's going to come in and strike this plate over here, and then it'll be coming down, hitting this one, and then basically bouncing back up there. So I'll just kind of draw this one as evenly as I can to that first one coming out. So again, the angle that's coming in here will be the same as the angle that it's leaving here as. So it's coming in this direction. Now when it hits this one here, I do want to draw then just another normal line. And so my normal line is just going to be that line perpendicular to the surface. So we'll draw that one in there. And then this one will leave that at basically then that same angle. Now, when I'm solving for those angles, then we just can use the angles in a triangle. So I can see that I form a triangle here with this 32 degrees between the two, and then this incident angle, and then this one down here. So this one here is coming in at an angle of 60 degrees. So the reflected angle is 60 degrees. That means the angle from the surface here is going to be 30 degrees. Now the angles in this triangle here must add up to 180. So 30, 32 gives me 62. That means this bottom angle here, which is this whole angle from the mirror surface to this incident angle, is going to be 118 degrees. Now I know though that my normal line is 90 degrees from the surface, so that's this angle over here. So if I take 118 minus the 90, that'll give me then 28. And so then this incident angle here must be 28 degrees, and that's just then this angle then to that normal line there. Now, if my incident angle is 20 degrees, then my reflected angle, which is this one over here, must also be 28 degrees because those are the same. And so my overall angle of reflection then off that second mirror will be 28 degrees. Now watch with your significant digits for these. We're just adding and subtracting angles, and so decimal places will be the rule then that we're using for our significant digits here. Okay, now for this one here, the first thing I'll do is I'll just draw the path of the light. Again, now we're just adding a third mirror. And so this one here, again, we'll just try to match the angle in that we had. Now we'll draw in a normal line on this one here. Okay. And then that'll, again, we'll just try to, as best we can, make those two even. We'll draw another normal line on this third mirror array. And then we can draw our line coming out. And again, we're just trying to make each of those a little bit even there. So Again, it should be the same angle in and out for all of those cases. Then we can then draw on just our angles. And again, remember the big thing we're looking for here is the sum of the angles then is going to equal 180 degrees. So if this one has an incident ray of, or incident angle of 60, I have a reflected angle of 60, and so this one then here will just be a 30-degree angle. So I have a 30-degree angle, 110-degree angle. That means this angle inside the triangle here is going to be just 40 degrees. Now, the reflected angle, or the incident angle, and then the reflected angle is going to be 50 degrees. But actually, I'm not interested in this one. I'm interested in the one down here. So I'm actually just going to carry through this angle from the surface. And then I'll just solve my next triangle over. So the angle of the reflected beam from the surface will be 40 degrees. This one's 85 degrees. And so once again, we'll do the sum of the angles in the triangle. And so if this is a 55-degree angle, then those three will add up to 180 degrees. Now 90 minus that 55 will give me then the angle of incidence, which is 35 degrees. And of course, because the angle of incidence and angle of reflection are the same, this one will also be 35 degrees. And so my angle in total then, or my angle of reflection off that third mirror will just be 35 degrees.